Future people. It's 1st of July. It's 2024. It's 9:04 a.m. Pacific. Just, yeah, I don't know why you needed the time, but you did. And now we have demos. Let us begin with Nick.
All right. I will be. I have two demos. Here we go. Okay. Actually, let's quit things that may show pop-ups because I can't remember if I configured do not disturb on this machine. Okay, so what I'm going to be showing is before functions depending on before functions. I will explain what this does once I reload my brain fully here and get rolling. So what we're going to create is an ECR credential to showcase this. And I'll copy and paste some code into the asset builder. What you're seeing as far as the little individual methods are subject to change, but the overall idea is that now you should be able to create secrets that depend on other secret components. And you see here we have an ECR credential, which is going to be of like the Docker Hub credential or maybe container registry credential annotation. This is subject to change, but the ECR credential for myself for the Elastic Container Registry is going to be personal access token and username. But then I also taken a secret prop of AWS credential in order to be able to create an ECR credential there. And I'll add a secret prop, which gives me an input socket for an expected secret. And I'll define a secret, which gives me an output socket for the secret I've defined here. And we're going to create an authentication function here as well. So let's go to auth and we'll call it ECR auth. And what an authentication function does, in case you are unfamiliar, and we won't make it error, we'll just make it log for now. What an authentication does is it takes in the value of a secret and then mutates your environment so that the component you're operating with can use it. So if we show this off in System Initiative, we will go AWS credential here. We'll do ECR.
You need to regenerate the asset.
He did.
Oh, thank you.
maybe
Thank
not.
you. It showed up in the list, but you're right. I never regenerated it. There we go. Now, and that failed. I haven't seen that before. Probably because I created the auth func before I regenerated.
No.
I've never seen that bug in my life.
Oh, I have. Just refresh. Hard refresh the web.
Just refresh and I'll be good. Okay.
I don't know if you'll be good. Probably you won't.
Okay. I can be very expedient and throw out this change set.
Yeah, you're done.
All right. So let's do this. Create change set. We're in a change set, create an asset, ECR credential. There we go. And now we're in. Now I'll copy and paste. Then I'll regenerate. And now I'll create an auth. We'll call it ECR auth. And then we'll do console.log success. The contents of this really don't matter because we have to do some extra work this upcoming week to make sure that we can actually use this in a meaningful capacity. So what I'll do is I'll come here. I'll do AWS credential. So now we're back to where we were. Fuzzy Finder search is not working. So that's something interesting. We'll do Docker Hub credential and set it here. So in our instance, what that function, that console.log success would do, would know that the AWS auth func ran so that it could generate its own credential on the fly using what the AWS auth func manipulated in the environment and then able to create an ECR credential on the fly. What we're going to do here is we're going to create an AWS credential. The contents do not matter for the purpose of this demo, so I will give it dummy values because what this demo shows, probably should have said first, but there's like a lot of buildup, is the order of before funcs is now respected based on relationships in the graph. So the AWS before func should run always before the ECR one. And we're doing this live here. And then anytime you mutate anything in Docker image, that will change as well. So let's do this. We'll go here to SDF. We'll clear the logs. And what I'm going to do is mutate something on Docker image so that a before func runs. So I just updated the image field, and we'll see. We'll go look at the look here. And there are a few examples. I'm dealing with some deduplication. But what you'll see is AWS Authenticate with SSO EMV vars always sorts before ECR auth. And this is true anytime you see this happen. What I did was I debugged in the code here. Anytime that we collect all the funcs and secrets from the tree that we climb, we will basically just reverse sort it for now. We're going to perform some more advanced graph dependency chaining later, but this was just more of a, am I sure this is going to work as intended? But how it works at a high level, and there are panics here, which I make sure the code will not let me compile it, will not let me check it in as a result. So rest assured, no panics in the DAO. Basically walks back every component that's connected and then essentially looks at the attribute prototype arguments and checks whether or not it comes from an input socket or from a secret. If it's from a secret, we know that it's set on ourselves, and now it's time to get the auth funcs. And if it's coming from an input socket, then we know that we have to check both explicit connections and inferred ones by frames, and then know that that's the next component to push back. And then that concludes this part of my demo. So we're going to formalize that code in a bit and get it into a clean PR. The second demo I had is, and I should say, what that unlocks is the ability to chain secrets. We have some follow-up work with connection annotations needed in order to make it work better, but that's the first bit. And then for the second demo, this was like a week or two ago, I consolidated all of our docs in the one docs file. This is because the files kept referencing each other and you couldn't really control after the repo. So if you have any questions about mainly developing system initiative, like using local stack, using Buck2, what's the repository structure? So this will talk about what you should put in the endpoint field, or the Buck2 will give you like a structured like way to use commands. Now it's all in one file, just docs.md. So if you have any questions about mainly developing system initiative, this is where you should go. And that concludes my 2 demos.
Cool. Thank you. Yeah, I'm looking forward to chaining secrets because it'll let us deal with all of the like weird esoteric edge cases, like you have an assume role that assumes a role that assumes a role, right? Or you have, like in the case of ECR, in order to get the token that talks to the registry, you have to auth to AWS first. So it's auth to AWS, then get your token, then do the thing. So all of that like token swap style auth becomes easy to express in system
It
initiative.
actually allows
Very
us
cool.
to do things like upload containers to the ECR registry as well, right?
Yeah,
So
right in the
yeah.
end, right? Because you actually have permissions now. Okay.
Yep.
So I'm gonna talk.
Kind of disappointed Nick didn't do a CrossFit demo, just saying.
Yeah, me too. Okay, so we'll have him do something with kettlebells next time. So
Yeah.
here's okay, so I'm gonna talk about IAM. So I've been knee deep in trying to model IAM, and I'm gonna show basically creating an IAM role, and then a policy to attach to it. Yeah, I'm gonna create an IAM role. I'm gonna attach a policy to it, create a user. It'll be fun. So we'll start with a user. So we'll give me a path because we're not heathens, and we'll call it Adam. You can see like it's gonna go and create like who we are. We'll take that user in a minute. We'll use it, but we'll create a role first. So IAM roles are things that users become. So a user decides to sort of opt into a role, basically. So what we're going to do here is we'll add IAM roles have a policy that's attached to them, the assume role policy. That's the one that basically says, hey, this is, well, we need one of those too, but we need a policy statement. The assume role policy is the one that says who is allowed to become this role, basically, and what can they do once they get there. So we can add a policy statement here. We're going to want any user in our account to be able to become this role. Let's say this role lets us create ECS clusters. We'll call it ECS manager, right? So here we've got a policy statement. We need the account principal. So the account principal is what you think it is. It's basically, oh wait, we need an account principal. Sorry. We need the Is it the account principal? Yeah, it is the account principal. I don't know why I second guessed myself. So we take the account principal. This is the actual, in this case, it'll be local stack. So this will be like anybody who uses local stack is allowed to get here. But then let's say we only want them to be able to do this if they have MFA enabled. So we can add a condition. We're going to set it manually. And we'll just say, hey, you can only do this if MFA is true. And then here we need to add one more thing, which is an action of STS assume role. And once it's done, after a furious amount of updating, the subsystem's a little in flux right now, but you can see everything's populating through. So now you've got a role that you can use that basically says, hey, you can assume anybody in the account who has MFA turned on can turn into this role. Now we need to say like what it is that people who can use that role can do. So in the end, our user Adam would be able to like come and make this happen. Let's change this name to ECS role. All right. So then we can make a policy that says this user is allowed to create cluster, describe clusters, and list clusters. And then the effect is that it's an allow. This is ECS list. We'll say, oh, we have to say any cluster at all. So which cluster is it allowed to be in? So we use this any here. And we're actually going to use this one too. We're just going to make sure that any resource that they ask for, they're allowed to use, basically. The same ones here. So you're allowed to manage any ECS cluster this way. Once this is done updating, all right, so now we've got a policy, a user, and a role. So if we want to make that role use this policy, we'll attach one here. So we'll take the role here and the ARN, and then we can do the same with the user policy. So we can say, hey, this user Adam, he also can use this policy, even if he's not in that role. So he can do it directly, because obviously, right?
This is already so much better than IAM anywhere else.
It's pretty good, yeah. So then, yeah, so now we can apply this change set, and what'll happen is we'll create this role, we'll create this policy, we'll create that user, then we'll attach the role and the user. Boop, boop, boop. So yeah, one thing that's fun is it figured out that it should do those three things in parallel, which is sort of obvious from the graph, but you can sort of infer the behavior, which is all three of those things need to be created. They don't have relationships to each other, so they can get created in parallel. And then the role policy and the user policy, those can also get created in parallel. because again, they're sort of disjoint sets. So it's fun to watch the system sort of figure that out. Yeah. And then while that's sort of finishing its way off, here's the resource that we actually created. So here's the actual role data. There's the user information. Here's the actual policy document. And then here's the actual attachments. There you go. That's my demo.
You actually saw hints of Wendy's work in there, where it was plus 151 hidden children.
Oh, that's
objects.
true. Yeah.
I figured that was too small to demo on its own and that it would show in someone else's demo.
It's pretty cool though. Yeah, we now hide unused object fields, which is pretty great for things like IAM conditions. All right, we'll see you all next week.